Alright, good day student. Today we'll be treating direct and inverse variation. You know what is direct and inverse variation? Our lesson will usually be the same for the time period before we be able to modify the way we treat it. I'm still your teacher, Lawrence Anashunamora. So today we'll be treating inverse variation and the direct variation. The first in 7.1 is classified direct and inverse variation. Classify direct and inverse variation. So this is the first. The second will be write inverse variation equation. Write inverse variation equations. So let's start with direct variation, and before we go to indirect variation. So two variables s and y show direct variation when they are related as follows. If two variables s and y show direct variation when they are related as follows. Two variables x and what? Y. If they show direct variation, if they are related as follows, y is directly, this means direct proportional to x. So if we put a constant, which means that if y increases, s increases in the same value, y decreases, s decreases. So let a be a constant of variation. Constant of variation. In this case, if we remove this symbol of relationship, we have y is equals to what? Ax, where a is what? Constant of variation. So two variables show direct variation if they are related as follows. In this case, a is not equal to 0, non-zero constant. So when two variables are in this form, we say that they are in direct variation. In this case, we say that y is said to be vary directly with what? With x. With x. So direct variation, this is the relationship between y and x, where a is a constant of variation. So in this form, we say that they are in direct variation. Example of direct variation. Example of direct variation is y over 5 is equals to x. So this is an example of variation. It can as well be y is equals to 12x. So in this case, we say the relation y is directly proportional to what? X. So any relation in this form is in what? In direct variation. So the next is what? Inverse variation. Inverse what? Variation. So we are now in inverse variation. Two variables s and y are said to be in inverse variation if they have the if the relationship between them is in this form, y is equals to a over x. That is, how do we arrive this? Y is inversely proportional to 1 over x. So in this case, if we put a constant of variation, constant of what? Variation. If we put a constant of variation here and remove this symbol, we have y equals to a over x. Say a set of data that is in this form, we say that they are in inverse variation. This means, this constant of variation means that when y is increasing, s is decreasing. If s is increasing, y is decreasing. So let's say if we have y1 is equals to a over s1. In this case, we have y1 s1 is equals to a. So if, let's say, we know what a is, the constant of variation is, and we know the value of y1, we can predict what the next value of y2 could be. This a means that y1 s1 is equals to y2 s2 is equals to what? y3 s3, and so on and so forth. So this is the relationship. In this case, we say that it is inverse variation. Y is said to be varied inversely with x. So in this case, y is inversely proportional to what? X. Y is inversely proportional to x, or y is said to be varied inversely with x. So mind you, this case a is still also not equal to 0, non-zero constant, non-zero constant. So in this case, you say that a is still what? Non-zero constant. So let's proceed. So the next is what? The next is classifying equation. Let's solve some equation involving inverse and what? Direct variation. In this case, we'll be able to understand the formula which we have written down. So classifying equation. How do we classify equation? Classifying equation. Tell whether s and y show direct variation, inverse variations, or neither. Tell whether x and y show direct, inverse, or neither variations. So this is given to you. You are required to show if any of these is direct or inverse or neither variation. For s is equals to y. So what type of relationship is this? In this case, the first thing is to state the relationships you know. You can say for direct variation, we have what? Y is equals to what? Ax. Then for inverse variation, we have that y is equals to a over what? X. So with what type of variation is this? So looking at these two, you will see that this is what? Direct variation. So in this case, for s equals to y is what? Direct variation. So this is how you can determine the type of variation you are given. Sometimes the given equation may have no value. It may not even be a variation. For example, okay, let's continue. So the second question is sy is equals to 12. So what type of variation is this? Looking at the two I have stated, if you look at this one, we have y is equals to ax. If you look at this, we have y equals to a over x, where a is a constant of variation. This is a number. So if you cross multiply, let's say y is equals to a over x. So you can say multiply both sides of the equation by what? X. If you multiply both sides of the equation by x, you have x times y is equals to a over x. I hope you are following. Times x. So x can cancel out. So we have what? Sy is equals to a. So looking at these two, you see that this is inverse variation. So you have seen that is what? An inverse variation. So in this case, you can conclude that the given equation is what? Inverse variation. So this is a type of what? Inverse variation. So let's continue. Have any question? So look at this type of another equation. So the next is the third one. This is the third one. If we are given s plus y equals to 6, the third example, s plus y is equals to 6. So what type of variation is this? We have stated that for direct variation, we have stated that direct variation is what? Is in this form: y is equals to ax. Inverse variation is in this form: y is equals to a over x. So looking at this equation and these two given equations, do this resemble any of them? No. So s plus y equals to 6 is neither what? Direct or inverse variation. So in this case, this is what? Neither this or what? It's neither direct variation or inverse variation. So having known how you can identify direct or inverse variation and neither variation, you can do this one. Given sy is equals to 1 over 5. So which type of variation is this? So you can do this one to know if you understand it. Sy is equals to what? Is equals to 1 over 5. So the next is classifying data. How do we classify data? Classifying data. So general equations of direct and indirect variation. So have you copied it? I can now clean here. So for example, I hope I'm not very fast. Direct variation, we've already known that direct variation is of this type, y equals to ax, and we can write it as what? Y over x equals to what? A, by dividing both sides of the equation by x. So having done this, a set of data pairs, you know what is a set of data pairs, S and Y, show direct variation. If they show direct variation, when the ratio is in this form, y over x are constant. If the ratio is what? Constant. A set of data pairs, because of s, y over x are constant. That is equals to a. That is equals to a, or there is no change in the set of data. For example, a set of data pairs sy show a ratio, a direct ratio that is constant, that is y over x. We say that that data is in direct variation. For example, if you are given 4 2 8 4, you see that here is y, here is x, this is s, this is y. So for example, ratio, if we compare the ratio of this, that is y over x, you see that 4 over 2 is equals to what? 8 over 4. You see this one, s1 y1. You know the ratio is constant. 4 divided by 2 will give us 2. 8 divided by 4 will give us 2. So in this case, we say that the ratio is what? Constant. So a set of data pairs sy shows direct variation when the ratio y over x are constant. I hope you are following. So the next is inverse variation. For an inverse variation is given as inverse variation is given as y is equals to a over x. So it can be written, you can write it as what? Yx is equals to a. So a set of data pairs sy shows inverse variation when the product sy are constant. If the product sy is equals to constant, we say that the set of data is what? Is in inverse variation. Is in what? An inverse variation. If it chose a constant, that is, if you multiply s with y, the result is always equals to the constant. Then we say that that set of data pairs are in what? In inverse variation. So let's quickly do some examples for you to understand what I have said. So let me put it here. Direct variation. We have that ratio that is y over x is equals to a. Then inverse variation, product that is sy is equals to a. So you have to know this. So let's do some examples. I don't know, there's not have enough space on this. Tell whether S and Y show direct variation, inverse variation, or nada. Tell whether S or Y show direct, inverse, or nada variation. So you see it. So from here you have S and Y. 12, 8, 23, 29, 34. You see it? So in this case you have 132, 198, 253, 319, and 374. So you are required to show whether this set of data SY show direct, inverse, or neither variation. So how do you go about it? Let's quickly do something to see if it is possible. First of all, find the product of SY and the ratio. So this is what we are given. Our first solution, product, find product. I hope you are seeing the product SY and the ratio YX. So let's quickly see if this is possible. We say for product, so we multiply 12 times 132 is equals to what? Use your calculator to multiply it. That is 12 times 132. If you use your calculator, you have 1584. So do the second one. 18 times what? 253. This will give us what? 18 times what? 198. 18 times 198 will give us 3,564. You know what I do? 18 times 198, 12 times 132. So by merely looking at this two products, we don't need to do everything. Just look at it. You see if their results are the same. You notice they are not the same, and for that reason the products are not the same. Inverse variation is a product form. So as you see, the products are not the same, therefore the set of data is not inverse variation. So the next is to check for the ratio. I hope you are following. We don't need to do all of them. Only 2 or 3 will justify whether it is inverse or direct. So let's go for inverse variation. For direct variation, sorry, let's check the ratio. Y over X. In this case, 132 divided by 12. Do divide it quickly. And 13 divided by 12 will give us 1. There's 1/12 in 13. You carry 1, put it here. 12 divided by 12 will give us 11. So we do the second one. Y over X is equals to 198 over what? 18. 19 divided by 18 will give us 1. You carry 1, put it here. 18 divided by 18 will give us 1. So you see, this is showing. But in order to satisfy, because we do have neither, since one is promising, we have to complete all them to make sure that all of them is in in order. That is, it is direct, because inverse variation, we have already noticed by the product rule, they are not constant. So let's complete this. Next is y over x for the third row, 253. I hope you are following. 253 divided by 253 divided by what? 23. So let's see. 25 divided by 23 will give us 1, carry 2. 23 divided by 23 will give us 11. So it is still promising. We go on for the fourth row. Y over x is equals to 319 divided by 29. So I hope you are seeing it. 319 divided by 29. So 31 divided by 29 will give us 1, carry 2. 29 divided by 29 will give us 11. And finally 374 divided by 34. So 37 divided by 34 will give us 1, carry 3. 34 divided by 34 will give us 1. So finally, we already see that the ratio are constant. Therefore, what type of variation is this? This is direct variation. So it is a direct variation. So this is one method. This is a method you use to identify whether a given set of data are in direct or inverse variation or neither, using the product rule and the ratio rule. In this case, the ratio rule we use show that the constant the data pairs of data, sorry, the set of data pairs are what? Constant. So in this case, it is a direct variation. So let's continue. Let's do some another example for clarification. So the next is, let's do the second example for clarification. So put the table of data, example 2. You put your data, a set of data. Here is x, here is y. Have 4, 6, 8, 8.4, 12. So here is 21, here is 14, 10.5, here is 10, and here is 7. So you are required to prove or show that if this is inverse or direct variation. So the first is to use the product rule. In this case, 4 times 21, 4 times 21 will give us what? 84. I hope you are seeing it. You do the second one. 6 times 14. 6 times 4 will give us 24. You write 4, carry 2. 6 times 1 will give us 6 plus 2, 84. You do the third row. It's promising. You see the constant, the result is the same. So the third row, 8 times 10.5. 8 times 5 will give us 40. You rise 0, carry what? 8 times 4 will give us what? That will give us 84. Because for example, See how you do it. 8 times 10 will give us 80. 8 times half plus 8 times half will give us 4. Therefore 80 plus 4 will give us what? 84. So you write it down. The next is the fourth rule. 8 times 4, 8.4 times 10 will give us 84. 12 times 7 will give us 84. So looking at the products, you don't need to go for the ratio. So in this case, since the product are constant, the ratio of the product are constant, we say that is what? Inverse variation. Inverse variation. So this is inverse what? Variation. So this is how we can identify a set of data pairs by applying product and ratio rule to say if it is a direct or inverse variation. So let's do the final example. To see if actually you understand the concept, and then we now proceed to the next step we have. So the first is S and Y. We have 4, 16, 5, 11, 6.2, we have 10, we have 7, we have 9, we have 11, we have 6. So this is another set of data. How will you actually find the product or the ratio? So let's try the product. SY, we have 4 times 16. 4 times 6 will give us 4, carry 2. 4 times 1 will give us 4 plus 2 will give us 64. So we have the next is 5 times 11. 5 times 11 will give us 55. So from here you see that the data is varying, they are not the same. So you can try the third one. You have 6.2 times 10, you have 62. So from here you know that the product doesn't hold since it's not constant. So the set of data is not an inverse variation. In this case, we now try direct variation. So ratio, if you are given another ratio, y over x, so you have y is 16 over 4. 16 divided by 4 is 4. So you have another one, 11 divided by 5 will give us 2.5. So you see that the ratio is also not constant. You can try the third one. 10 over 6.2. 10 over 6.2 will give us 1.61. So by merely looking at it, you will see that the ratio also, we have tried product, it doesn't work. We tried the ratio as well, it doesn't work. So we conclude that since it is not a direct and also it is not a inverse, the set of data is neither. So the result is what? Neither. So this is how you can quickly test for a set of pairs, a set of data pairs, to justify whether it is an inverse, direct, or another variation. We can now move to the next section of what we have. Have any question? So the next is what? The next is writing inverse variation equation. Writing inverse variation equation. So writing inverse variation equation, writing inverse variation equation. Okay. No, sorry. Writing inverse variation equation. The variable s and y varies inversely. Use the given values to write an equation relating s and y, then find y when s is 3. So writing inverse variation equation, the variable x and y vary what? Inversely. Use the given values to write an equation relating s and y. Equation relating s and what? Y. Write an equation. Write an equation. I hope you are following. Relating s and y. Then find y when x is what? 3. So the first one is you are given s is equals to minus 3 and y is equals to 8. So in this case, you are told that the relationship between s and y are inverse. It's an inverse proportion. So you are given a set of data and then given one other values of the given other value, which is x. So you are required to do what? Write an equation relating s and y and then find the value of y when s is what? 3. So the first thing is to state the relationship between them. For inverse variation, y is equals to what? This is an inverse, a over x, or what? Y or s, y is equals to what? A. So this is the relationship between them. So from here you can use the relationship given that a is equals to sy. So here you are given minus 3 and the y is equals to 8. So a is equals to minus 3 times 8 to give us minus 24. So minus 24 is the constant variation. It's what? The constant variation. So therefore the equation, the relationship, this is between s and the y. Relationship between s and the y is equals to, given sy is equals to a. That is it. So we have know that a is equals to minus 24. So sy is equals to minus 24. So this is the relationship between them. Or you can also write it in this form: y is equals to minus 24 divided by x. Any of these equation satisfy the relationship between s and the y. So we proceed because we live in I live where we speak other language. So sometimes I try to speak the language of where I am living. So but all the same, the second equation. I hope you got it. So let's do more examples for you to understand how to write inverse variation equation and then find the other value when one of the other value is given. So the second equation or example, you are given s to be minus 4, y is equals to minus 5 over what, 4. So this is the second example. So we know that for inverse variation, we have y is equals to a over x, or yx is equals to a. So is equals to a. So the next is to, having known the relationship, that is the inverse variation equation, to find the relationship we have to substitute the values of s and y in the equation so that we can get the constant variation, and then put the value of x in the relationship to find the value of y. So let's proceed. Here we have that y is equals to minus 5 over 4, and the a, we don't know what is a. We know that s is equals to minus 4. So this is it. In order to make a the subject of the formula, we multiply both sides of the equation by what? By minus 4. So you multiply both sides of the equation by minus 4. In this case, here this can cancel to give us a equals to minus 4 times minus 5 over 4. So that 4 can cancel out, and multiplication of the same sign possible, we change it to what? Positive. I hope you are seeing it. If you multiply minus times minus, the result is equals to plus. So we have what? 5. If we put plus before 5, so you are still treating what? The knowledge of what? Direct numbers. So we don't usually put plus when it is in ordinary mathematics. In this case, the answer is 5. So if you write this or this one, the answer is still the correct. So this is the constant of variation. A equals to what? 5. So let's get the relationship or the equation relating s and y. So in this case, you move x to this side, or as we have seen, so you can always use this one. In this case, I have x y is equals to what? 5. Sy is equals to 5. Or if you can write it in this form, sy is equals to 5, or you can write it in this form, y is equals to 5 over what? Over x. Any of this relationship will give any of this formula or the equation will satisfy the relationship between s and the y. So do you have any question? So having gotten that, the next is to do what? The next is to find the value of y. To find the value of y, so to find the value of y when s is given as 3, when s is equals to 3, from this relationship we have y is equals to 5 over what? 3. So this is the value of y when s is equals to what? 3. Have any question? So if you don't have any question, we can proceed to solve more examples and then we move to the next section. So the third one, you are given that x is equals to 5 over 3, y is equals to minus 7. So you are required to write the equation relating them. We are still in inverse variation. So y is equals to what? S over x, or is equals to what? Y is equals to what? So or sy is equals to a. So knowing these two relations, we can find the relationship. In this case, we can find the relationship between s and y. So from here, you can use this formula to find a. So a is equals to what? 5 over 3 times minus 7. So this will give us minus 35 over what? 3. So this is the relationship. Once we have gotten a, you can substitute this in this equation to get the relationship between s and y. So from here, you have sy is equals to minus 35 over 3. This is the first one. Or y is equals to what? Minus 35 divided by 3a. Minus 35 divided by what? 3a. So this is the relationship between them. So the next is to find y when s is what? When s is 3. What is the value of y? You can here, this is x. So this is the relationship between them. So when s is 3, y is equals to minus 35 divided by 3. S is given to be 3. So in this case, we have what? Minus 35 divided by 9 is the value of y when s is what? 3. Have any question? If you don't have any question, we now solve one problem in modeling using inverse variation, and then we so let's so this is where I think this is where we stop today. This is where we stop today. I don't have any question. We have already solved all the important areas which you are required to do. So usually this is where we stop. So okay, let's do one modeling question and then we round up. I can quickly make out plan for it. Modeling, inverse variation modeling. So there's a device can store 2,500 songs can store 2,500 songs a device can store 2,500 songs in MP3 when the average when the average when the average size a device can store 2,500 songs. In this case, this is a value of y. In MP3, when the average size x of song is what? Is 4 megabytes. A device can store 2,500 songs in MP3 when the average size s of song is 4 megabytes. So in this case, you are given some data, some pairs of data, and then you will ask question based on the set of data. So the first is you are given a set of data. In this case, you are required to find the number of songs that can be stored. A device can store 2,500 songs in MP3 when the average size x of song is 4 megabytes. Find the number of songs that can be stored when the average size of song are 2 megabytes, 2.5 megabytes, 3 megabytes, and the what? 5 megabytes. I hope you are seeing it. So you are required to do find the number of songs that can be stored when the average size x of song are 2 megabytes, 2.5 megabytes, 3 megabytes, and 5 megabytes. This is I. So the second question is what happened to the number of songs when the average size is what? When the average size is increasing. What happened to the number of songs when the average size x of song is increasing. You got it? When the average size is increasing. This is a question. So go through the question and then let's solve the question. This is a model N using inverse variation. A device can store a device can store 2500 songs in MP3 when the average size S of song is 4 megabyte. Find the number of songs that can be stored when the average size X of song are 2 megabyte, 2.5 megabyte, 3 megabyte, and what? 5 megabyte. What happened to the number of songs when the average size S of song is increasing? You can write the question down so that we can solve the problem. You can pause the video, write it down, and then follow up in the solving of the question. And let me clean the board. The first thing to do is to create a table of values for S and the Y. That is, the Y is what? The number of songs. YS, number of songs that can be stored. YS is what? The average size of the song in megabyte that can be what? Can accommodate the given song. That can accommodate what? The given song. So the first is what? Draw the table of value. So this is S and the Y. You are given already. You are given 4,000. 4,000. Let me don't repeat it. So let me put it in the table of value. Be looking at the question. If you have write it down. You have written it down. So 4,000. We have 5,500 songs that can be stored. Know that this is in megabyte. This is in megabyte, and this is songs. So the next is 2,000 megabyte. We have 5,000 songs that can be stored. 2.5 megabyte. We have 4,000 songs. Next is 3. You have 3 point what? 3. Know how we got this value? If it's 5, you have what? 2,000 songs. So because we are treating what? Inverse variation modeling. So the relationship between S and the Y is Y is equals to A over what? X. The first instance was given to you 4,000 and 2,500, 4,000 megabytes and 2,500 songs that can stored. So you are given values of this, and you are required to find the number of songs that can be stored. Looking at the relationship as an inverse variation, we can find the constant so that we can use the values of S given to find the values of Y. So from here you have A is equals to SY. We are given that S is 4 megabytes and the Y is 2,500 songs. So if you do the multiplication, you have 10,000. Sorry. So the constant of variation is what? 10,000. So you can put it here. 10,000 is equals to SY. Again, you are given 2 megabytes. Required to find the number of songs that it can be stored in the device in MP3. So in this case, you have Y is equals to 10,000 divided by X. We have what? 10,000 divided by 2. That will give us what? 5,000. So this is how we got the values of Y in the table. The next is Y equals to 10,000 divided by X, 2.5. So we have what? 4,000. This is how we get 4,000. And if you do the rest, Y is equals to 10,000 divided by 3. You have what? 3,333.333, and so on and so forth. If you do for this one, Y will be equal to 10,000 divided by 5. You have 2,000. So this is how we got all these values in the table. So you have any question? So let's look at the table. You have already gotten the first question, the answer to the first question. 5,000 megabyte when it's 5,000 songs when it is 2 megabyte. 4,000 songs can be stored in MP3 when it's 2.5. 3,333 3,333.33 song. Unfortunately, it can be, maybe you can approximate it to 3,333, or you can still leave it because half of the song. So in this case, 2,000 songs can be stored in MP3 when it is 5 megabytes. So the second question is, what happened to the number of songs that can be stored? What happened to the number of songs that can be stored when when the average size of the song is decreasing? When the average size is decreasing, was given 4. Was given, if you look at the set, this is 4. We have 2,500. Already, when it is 5, we have 2,000. Are you seeing it? Sorry, the question is, what happened to the number of songs that can be stored when the number of the average size is what? The average size is, I think, is increasing. Sorry, it's decreasing when the average size is decreasing. So what happened to the number of songs when the average size of the song is what? Decreasing. At first, we have 4 megabytes. It was 2,500. So when we have 5 megabytes, we have 2,000. When we have 3 megabytes, we have 3,333. What do you notice? From 2,000 to 2005, from 2005 to 3,033. So when we have 2.5, it is 4,000. So when we have 2 megabytes, it is 5,000. So what do you observe? It is increasing. So when the number of when the average size of the song is decreasing, the number of songs is what? The number of songs that can be increased, that can be stored, is what? Increasing. So therefore, the number of songs that can be stored increases when the average size decreases. When the average size decreases. Do you understand it? I can write it here for clarification, because it's an inverse. They really wanted you to know if you understand the inverse variation, A over X. So looking at it, when we have 5 megabytes, the number of songs is 2,000 that can be stored. When we have 4 megabytes, the number of songs is 2,500. So when we have 3 bytes, the number of songs is 3,333. When we have 2.5, the number of songs is 4,000. Looking at this set, is it not increasing? So when we have 2 megabytes, we have what? 5,000. So when the average size of the song is decreasing, see it is decreasing from 5 to 2. The number of songs is what? Increasing from 2,000 to 5,000. Because it's what? Inverse variation. You can now say that number of song stored, that is Y, increases when what? When the average size x of sum decreases. So this is where we'll stop today. Go through all we did. If you have any question, send the question to me for solution. Now we move to 7.5, the next section, graphing rational function, and then from there we proceed. Have any question? So see you in the next lesson. Bye for now.